Okay, good. So let me start again. So good evening. So I am recording this, and what I do is I upload it to my YouTube site and send it to everybody. But I will do that later on tonight or first thing tomorrow. Anyway, so welcome to our class. So for the first 3 weeks at Mesa College, it's going to be virtual. So we're just in the virtual classroom right here in my living room. And then on week 4, we go into the classroom in the Math and Science building, room 118, which is also on the syllabus. So everybody should have gotten a copy of the syllabus. So I sent that out to everybody. It's also on Canvas. So I do have the Canvas shell open for this class. So you should be able to go to it. And that is also listed in the upper right-hand corner of the syllabus. Let's see, some basic ground rules right there. Let's talk about some other general announcements for the college. So one thing is parking. So when we come back on week number 4, there's no parking fees this semester. So you don't have to pay for parking. If you already paid for parking, then they should give you a refund for what you paid for. But remember that you can only park in student areas. So you can't park in any faculty or staff position, or they will give you a ticket. So, but parking is free this semester. So that's good. That's one thing. Let's see, what's another thing here? Remember that on campus, it's a masked environment. So we will be wearing masks in the classroom unless otherwise advised. And that means me too. So I'll be teaching with a mask on, which luckily I have enough volume to do that. So everybody is able to hear me in the classroom. And I hope I'm coming out loud and clear now to everybody here in the Zoom room. Let's see, what other things do we have here? General announcements. Parking, we covered that. The bookstore is open Monday through Thursday from 9 a.m. to 5 p.m. and 9 to 2 on Friday. And we'll talk about our textbooks and how you can get them when we talk about the syllabus. Let's see what other things we have here. The scholarships. So remember, there's almost $200,000 worth of scholarship money available to students, anywhere from scholarships that are less than $100 to scholarships that are more than $1,000. And there's just oodles and oodles, like over 100 different scholarships that you could apply for if you meet the criteria. And you can find those through student services, either over in the student services building or in on the Mesa College website. If you go to student services, you should find information for scholarships. The thing on the scholarships is the deadline for application is February 17th. Now, sometimes they extend that one, especially now because there's such a short time frame before from the start of the semester to February 17th. I think I said, did I say February 17th? Yeah, that's the deadline for scholarship application. And oftentimes they'll extend that if they find out that people aren't aware of it or having problems getting their scholarship application in. And then the last general announcement is on the LRC, the Learning Resource Center, or our library. So that the library hours this semester are going to be Monday through Thursday from 9 a.m. to 4 p.m. And then let's see. And then it's open virtual in the evening. It's open virtually from 8. Excuse me. On Thursday. Let's see, virtual hours. Oh, here it is. Yeah, from 4 to 8 in the evening. It's open virtually, and then it's supposed to be open Friday virtually also. So the LRC is open. Just remember, it is a mask environment on campus. And they encourage everybody to get your shots and your boosters and whatever else. Okay, so any questions about general announcements like that? Okay, good. And again, once again, sign in the chat room over on the side there. So the first thing I'm going to do is go over the syllabus. Unfortunately, I have to read it. So it's very not exciting reading, but I'll try and read it as expeditiously as possible. And you should have, again, gotten a copy of the syllabus on the welcome email that I sent everybody. So I hope everybody got that. Yeah. Okay, good. Let me see if I can turn this on if it's not too bright. It's kind of bright. Well, I'll turn it off. Okay, good. So start in the upper left-hand corner of the syllabus. This is Math 96, Intermediate Algebra and Geometry for the spring of 2022. And our course reference number is 82129. In the middle there, we meet Monday and Wednesday from 7:05 to 9:30 p.m. And right now it'll be online for the first 3 weeks. And then starting in week 4, we'll be in Math and Science room 118. Okay, then over on the far right-hand corner, that's me. I'm Mr. Lancaster. My phone is 388-2767, extension 5189. So that's a message phone on campus. I don't have an office on campus because I'm adjunct. And so if you leave a message there, then sooner or later I should get it. But I don't check that message phone very often. So if you want to give me a message, then email me. And there's my email right there, mathroom@hotmail.com. Or you can do it through the school email site for me. But that's the best one right there, mathroom@hotmail.com. The one that if you do it through the through Canvas, that's my email, my official Mesa email, elancast@sdccd.edu, which is on the one through Canvas. So, but the easiest one to get a hold of me is the Mathroom one. Okay, and then there's the number for our Canvas shell, 2223, Mesa Math 96-82129. Okay, and that gives us our Canvas shell. So the Canvas shell is open. There's a copy of the syllabus on there. I will be posting homework on there, although we aren't going to be turning homework in through Canvas. And you can get a copy of the syllabus. You can also log on to the Zoom room through the Canvas site. And I'll put other information that I find pertinent to you, links to other information on there also from time to time. So getting back to the syllabus here. So our text is Elementary and Intermediate Algebra, Concepts and Applications by Bittinger, 7th edition. This is it right here. It looks like this. And you can get that through the bookstore. You can get a used copy. You can also get it through Amazon, which is the cheapest way, and you can rent it. Renting it is the cheapest way. I don't know if anybody's rented a textbook before, but last semester they were renting a textbook and it ran about 10 or 11 bucks, and they pay for shipping in both directions. So it's very, very convenient. And then they send it to you, and then you just put it in the package and send it back to them when you're done. You can also get an ebook. So you can get the hard copy. There's no soft cover copy of this to my knowledge, but through the bookstore, you can get a hard copy at a semi-outrageous cost, or you can also get an ebook version through the bookstore, and you can rent it through the bookstore. But the easiest way to rent it is online, or the cheapest way to rent it is online. And different people will bring up different. Did anybody rent it yet? Anybody out there? Okay.
Yes.
That is an option. Oh, Elaine, did you rent it?
I think I did. Yeah.
You did. Okay, good.
Yeah, I think I rented it too. It was like super cheap.
Yeah, it's super cheap to rent it. That's the easiest way to do it.
I did too.
Yeah. Okay, good. That's good. And if you put if you can put a link to your to the site that you went to rent it to when you over in the chat there, and then people can check that out. let's see. So getting back to our syllabus right here. So our other textbook is this one here. It's a little geometry book. It's a soft cover book, and it's available through Amazon. Again, you can get it for next to nothing. If you buy it, you can buy a copy, but it's soft cover. And we won't start using this until probably week 5 or 6. We'll start using that. But we will use it. Let's see. You also need a 3-ring binder and a scientific calculator. So you'll need a binder to keep your notes in. So you'll see that one of the things that I give you part of your grade is your notebook. So you should keep your notes in like a 3-ring binder or some other kind of binder. And I'll have more information on that in the syllabus. And then you also need a scientific calculator. Whoops, there we go. Basic scientific calculator like that. Okay. You can get one really inexpensive, usually less than about 10 or 12 bucks at Target or someplace like that. Also, during test days, I will have scientific calculators available. But the thing is, and I didn't put this comment in there, but it should be in there. You can't use your phone as a calculator on the exams. So I usually bring in about 8 calculators that I can pass out to people that they can use during the test. Let's see. So the objective of this course is to extend the understanding of algebraic and geometric concepts with an emphasis on logical thinking and practical problem-solving applications, which means like word problems. And specific student learning objectives are listed below. So there's 12 of them right here. Unfortunately, I have to go through them. So number 1, solve systems of equations in 3 variables using a variety of methods, including matrices. Number 2, graph the solution set of a systems of linear equations in 2 variables. We might be doing that tonight. Number 3, simplify and perform arithmetic operations on radical and exponential expressions. Number 4, solve quadratic, radical, and exponential equations, including complex number solutions. Number 5, perform basic arithmetic operations with complex numbers. Number 6, identify and graph conic sections. Number 7, solve absolute value and nonlinear inequalities in 1 variable. Number 8, perform algebra with functions, including one-to-one and inverse functions. Number 9, use the properties of exponents and logarithms to solve application problems. Number 10, determine simple sequence patterns, including arithmetic and geometric sequences and series. Number 11, use arithmetic and geometric sequences and series to solve related application problems. And number 12, use 3-dimensional figure surface area and volume formulas to solve related applications. So a lot of stuff that we're going to be looking at there, and we won't even be able to cover all of it. So the course learning outcomes. So these are a couple of things that you should be able to do once you leave this course. So number 1, and we got 3 things here. Number 1, students will be able to demonstrate knowledge of the interrelatedness of the equation of a quadratic function and with its graph, including the vertex and x and y intercepts. Number 2, students will be able to demonstrate knowledge of the application of an exponential function, including the growth decay constant population at a specified time required to achieve a specified population, and the doubling time. And we'll be looking at those when we look at exponential and logarithmic functions. And finally, number 3, students will use correct terminology to identify geometric solids and their properties. And that's where we get to this textbook here. We're going to be looking at geometric properties there. So course content. So I haven't talked enough about it yet, so we got some more here. So using problem-solving approach, this course includes rational equations, radical equations, complex numbers, quadratic equations and inequalities, systems of equations and inequalities, inverse functions, exponential and logarithmic equations, sequences and series, and the binomial theorem, conic sections, solid geometry, and an introduction to trigonometry. Phew. So we cover a lot of stuff. It's a 5-hour course, which means it does go rather rapidly as we move along here. Method of evaluation. Okay, now we're going to talk about how your grade is evaluated. So your grade will be determined by the cumulative points earned on a notebook. There's 50 points for your notebook. Homework, that's 120 points. 4 tests, that's 420 points, and a comprehensive final exam, 170 points, divided by the total possible points. So what does comprehensive mean? It means it covers everything in the course that we have covered. The final percentage will determine the letter grade. And then this final sentence is really important. There will be no, in capital letters, retakes, drop grades, extra credit, curving, or rounding up. So I don't drop your worst grade. I don't grade on a curve. Okay, all of that is too difficult mathematically, so I don't do it. You just get a straight up grade. So there's no curving and no drop grades. There is extra credit from time to time. I'll put extra credit problems on every test, so you can actually get more than 100% on every test. The grading scale. So A is 90 to 100%, B is 80 to 89%, C is 70 to 79%, C is 60 to 69%, D is 0 to 59%, or F is 0 to 59%. Note, pass or no pass must be applied for. Pass, no pass courses may not be transferable. So typically they're transferable to other community colleges, especially in the San Diego area. But this course is not transferable to a 4-year institution. So the first, only the 3 number courses are transferable to 4-year institutions. So the first 3 number course is trigonometry, Math 104. Let's see, makeup exams. Makeup exams are strongly discouraged. And then in bold type it says, do not miss a test. And then further states, if you miss a test for an unexcused absence, you will be given a 0 for that test. Makeup exams are given by appointment only. Appointments must be made prior to the test and will only be accepted for excused absences. If makeup exams are unproctored, the maximum grade is 75%. Okay, now I'm a realistic person. I have a day job too. So I realize that sometimes people can't make it. Their work interferes, home life interferes, family life interferes, something like that. If something like that happens, just let me know, even if it's after the fact, and we'll make arrangements for you to make a makeup exam. Incomplete. To receive an incomplete, you must be passing the course or unable to take the final exam due to legitimate reasons beyond your control. So nobody wants to get an incomplete. Attendance. Attendance will be in accordance with the policy of Mesa College catalog. You may be dropped if you miss more than 3 classes and must be dropped if you miss more than 5 classes without a valid excuse. Excused absences are only those absences for which the instructor has been notified in advance of the class, meeting time, and in accordance with the Mesa College academic policy. Now, again, realistic here. So if you're going to miss a course, or you do miss a course, you have a flat tire, you can't make it, you had to take your dog to the vet, your kid to urgent care, whatever it might be, just let me know, even if it's after the fact, and I'll give you an excused absence. Tardiness. Being late for class 1 or 2 times during the semester is understandable. However, habitual tardiness will be sufficient cause to be dropped. You must be dropped, you will be expected to stay until the class is over to receive credit for attending that session. Okay, so typically this usually revolves around parking problems, but now with an evening class, there's no parking problem. Everybody can find a parking space, but we will have a 10-minute break in the middle of the class. This is a 2.5-hour class. So we will have a 10-minute break right there in the middle. So after the break, you need to come back in order to get attendance for the class. Okay, notebook. So here's the first thing that's a specific determining factor for your final grade. So you will be expected to maintain an orderly notebook containing at a minimum the course outline, handouts, class notes, homework, and exams. Notebooks are due on exam days. Class notes will contain at a minimum definitions and problem examples. Notebooks will be 10 points per exam. You may keep other course notes organized separately in the same notebook. So basically just a small 3-ring binder is all you need, but you need your homework in there, your class notes, the syllabus, any handouts that I happen to pass out in class. And I check those on exam day. So when you're taking the exam, I check the notebooks and then I give you credit. Okay, page 2. So homework. So the second thing that's a determining factor for your final grade. Homework will normally be assigned from the odd problems at the end of each section. I will check to see that they are done and that work is shown where needed. Homework will be 4 points per assignment and is due the first class period of the following week. Ask questions in class on problems that give you difficulty. So that was written for an in-class course for the whole semester. And obviously we aren't going to start in class until week number 4. So, and we aren't going to turn in homework. We aren't going to turn in digital homework through Canvas. All of our homework is going to be hard copy, paper, and pencil. Okay, so you can turn it in on week number 4. But other than that, during the rest of the semester, typically it's due on the Monday of the following week. So I'll give you homework assignments every class period. So you get a homework assignment on Monday, homework assignment on Wednesday, and they're due on Monday of the following week. And you can ask questions in class on any problems that you might have with the homework, or see me before or during class or during office hours. Academic accommodations. Every effort has been made to make this course accessible to all students. If you are unable to access the course, to assess anything in this course, or have a disability that may require special consideration, please contact me as soon as possible. So if you have something of that nature, just contact me. We can make arrangements. Behavior. Behavior will be in accordance with the San Diego Community College District Policy 3100 on student rights, responsibilities, and the Code of Conduct. If anyone exhibits deliberate habitual behavior which interferes with the class or any member of the class, they will be warned once, and the second time asked to leave, with appropriate action being taken in accordance with the Mesa Policy 3100. So, just behave. And everybody is adults right here, so we just treat everybody with respect and consideration. Cheating. Students will be expected to be honest and ethical in the pursuit of academic goals. Cheating on an exam will result in a 0 grade for that exam. Recurrence will result in a report to the Dean of Student Affairs and possible failing grade for the course. And there's no reason to cheat. My tests are really user-friendly. If you do the homework, pay attention in class, you can get an A on any test. So there's no reason to take a look at someone else's test and see what they're doing, because they probably got the wrong answer anyway. Office hours. Office hours will be held Monday and Wednesday from 4:10 to 4:40 p.m. in the LRC first floor study area, and from 6:35 to 6:55 p.m. in MS 118. Now, obviously, that's designed for a classroom class, and we'll start that in week number 4. So I may consider office hours here on either Thursday or Friday of the week, just so people can check in and ask questions. If I do that, I'll send everybody an email. And I tend to try not to do the office hours in the LRC. So hopefully the way I did it last semester is that the room before us, nobody used it. So basically I had the room for a couple of hour period before class and all the way up through class. So I was able to do office hours in the same room. And that's going to be my intent this time. So it just depends on if anybody's scheduled right before us. So I'll have more information on that when we come back to the classroom in week 4, and I'll let everybody know. What have we got? Schedule. The schedule. This schedule is flexible and subject to change to meet the needs of the class. You are responsible for schedule changes announced in class, whether you're present or not. So now I have the schedule for every day in the semester from today all the way through Friday, the 27th of May. Actually, the last day of the official schedule is Saturday, the 28th of May, because there is Saturday classes, but none of ours. So I just got Monday through Friday classes right here. But you can see in each under each class, I have the applicable sections that we should be covering in that. Now, those are ideal. That's really ideal and kind of exaggerated. Typically, we never cover it that fast. There's just too much material, and people need to be brought up to speed on items as we go along. So even though you were supposed to have beginning algebra before this and know how to basically solve a simple linear equation and things like that, people still have difficulties in that area. And I will try to bring everybody up to speed on different algebraic operations as we go along. But some points of interest right here. So the second Friday, so Friday, the 11th of February is the deadline to add or drop with no W, and it's also the refund deadline. So if you don't want to get a grade in the course, or if you don't want to get a W, okay, so you can only get so many W's or withdrawal codes in your academic record before they put you on academic probation. So you don't want to get those. So if you want to withdraw without getting one of those, then you have to do it by that date. That's also the date to get a refund. So then you can get your money back by that date. Coming back the next week, so Friday of the next week, that's Lincoln's birthday, and the following Monday is Washington's birthday or President's Day. So those are holidays in the community college district. So we won't have class on Monday, the 21st of February. And then we'll come back into the classroom on Wednesday, the 23rd of February, where we're going to do some new material. We'll have a review, and then we're going to do a test on that day on everything that we covered in the first 3 weeks. Let's see. And then going on down, Monday, the 7th of March is the pass, no pass deadline. So if you plan on doing it pass, no pass, and all that means is I give you a letter grade anyway. So you're going to get a letter grade, and then administration changes that to a pass, no pass if you want to go that route. But you might as well get a letter grade because I'm going to give you one anyway. Let's see. Then we got test 2. It's going to be Wednesday, the 16th of March. So that's test 2. And then we go down and finally we come to spring break. Yay. Everybody's ready for it by then. So that's from the 28th of March to Cesar Chavez Day on April 1st. So that whole week, there's no classes. So Mesa College is basically shut down over that week. And then we come back and we'll have test 3 on Wednesday, the 13th of April. So that's test 3. And then the withdrawal deadline is Friday, the 15th of April. So if you want to withdraw from the course without getting a grade in it, you'll get a W, you'll get a withdrawal code in it, but you won't get a grade in it. Then you got to do it by that day, the 15th of April. If you attend after that period, then I have to give you a letter grade in it. And if, for example, you just want to drop, a lot of people do this, they just don't show up anymore. Even if I ask them if they're going to show up, they say, yeah, no, don't drop me, I'll show up. And then they never show up, they don't take the final, and basically they get an F grade in the course. Let's see. And then we keep going and we see that Wednesday, the 4th of May. So now we're into May. So Wednesday, the 4th of May is test 4. So our last regular test, we got 4 tests and then we got the final. And then we go 1, 2, 3 weeks to the final. Well, we should start a review on Wednesday, the 18th of May. And then Monday, the 23rd of May will also be a review day. And then we come in and take the final on Wednesday, the 25th of May. Okay, and then just to show you that I got a good sense of humor, there's a cartoon at the back from Baby Blues, and it says, this is a good one. So it says, so little son there is asking his mom, Mom, I have a question about my math homework. Great, she says. Okay, we have some sharp pencil, scratch paper, good light, supportive chairs, and she's getting ready. She's going out to the kitchen table, and she says, so what's your question? And he says, why do I have to do my math homework? Okay, well, you have to do your math homework to pass the course. And I'll show you why as we cover some more specific items. But any questions so far on the syllabus? Okay, pretty straightforward. And again, you should have a copy of that. And a copy of that goes in your notebook. So that's the first thing I look for when I look at your notebook is the syllabus here. Okay, some other information then pertinent to the course. Most of this is designed around the classroom environment, so I'll just skip over a lot of this stuff. But on your grade, let's talk about that. So your grade is made up of 4 basic parts. So we have the final. Okay, and the final counts for about 20. In fact, let me rearrange this a little bit. Hang on. Where's my eraser? Let me not write the final first. Okay, we have the tests. We got 4 tests. So the 4 tests count for about 60% of your final grade. Okay, then we got 1 final. And that counts for 20% of your final grade. And then we got the homework. And that counts for 14% of your final grade. And then we got the notebook. And that counts for 6% of your final grade. And if you total this all up, it comes out to 100%. But, and this isn't going to be on any test or anything like that. But what I want to point out right here is this. Your homework and your notebook together count for as much as the final. Okay, so if you just do the homework and keep a notebook up, that gives you, that can actually boost your grade a half a letter grade. So for some reason you're having difficulties with my tests, even though they're super user friendly, then that can actually, you're pulling down a D with the test for whatever reason, that could boost you up to a C. It can boost a B up to an A. So it can boost your letter grade up about a half a letter grade. All right, so that's what I wanted to point out there. Let's see, what other things do I got to point out here? Let's see. Okay, the class time. So I use the full we got the classes basically 2.5 hours, and we'll use the whole time period. There'll be a 10-minute break in the middle right there. Let's see. If for the classroom portion, I don't show up, then you got to sit there studying for about 15 minutes and then you can leave. Okay, but I show up for everything, or I get a substitute. Let's see, what else? Okay, and all of my class methodology, my class structure is basically just like we're doing tonight. So I'll take, I take attendance. I take voice attendance every class when we're in the classroom, not on virtual right here. So that's what the chat is for over on the side. To just sign in there, that's your attendance. But in the classroom, I want to see you. I want to hear you. So I know that familiarizes myself with you and you with me. So that just helps us get better acquainted. But I'll take attendance, and then I'll do any administrative remarks, just like I did tonight. And then we'll answer any homework questions. So we'll have a homework review portion right there. We're going to answer any homework questions. And then we do the lecture portion, okay, where I'm lecturing from the book and doing, so my lecturing is doing examples and methods for everything that we do. Okay, I'm not just talking to you. We're doing stuff up on the board. On days that we have a test, I will do a review after we come back from our break. So we'll take our break a little bit earlier. We come back and do a review, and then we'll take the test. And the test will be my tests are designed, if you know everything cold, you've done all the homework, you've kept good notes, paid attention, come to every class, and you know everything cold, you can take the test in about 20 to 25 minutes. You can be done and out of there. Okay. But I give you more than an hour to take the test. And usually it's more like an hour and 20 minutes, even sometimes an hour and a half, depending on the particular subject matter that we're covering. So you have plenty of time to take the test. Let's see. And I'll follow the book. Okay. So you paid money for this book. I want to make sure that you get your money's worth out of it. There's lots of tutoring facilities, and as we get different information on that, I'll pass it out to class. There's actually some links in Canvas and at the Mesa College website to different tutoring options that are available on campus, even for virtual tutoring. They're going to do virtual tutoring through the LRC this semester, is my understanding. Let's see. Okay. Any other questions on the course outline, rules, procedures, policies, the course content, schedule, anything, calculators, whatever it might be, the book, et cetera, et cetera, et cetera. Any questions?
I actually do have a question, Mr. L. So
Yeah,
for
go
those
ahead.
of us that are using iPads and will be taking notes on our iPads,
Yeah,
how are you going to do that? Are you just going to look over the iPad and make sure we have notes for
well,
the book?
the notebook not only includes your notes. I mean,
Yeah.
you can have the iPad there,
Okay.
but the notebook not only includes your notes, but it includes homework.
Right.
It includes the syllabus. It includes any handouts that I pass out.
Okay.
And I know your syllabus can be on the iPad too, but you should print out a hard copy of your syllabus. So then, because you're going to be the notebook is going to be in paper, or excuse me, the homework is going to be in paper and pencil anyway.
Okay. Good to go.
Yeah. But no, I'm not going to get into your iPad or whatever it might be. Okay, good. Any other questions? All right. Are you ready to do some algebra? Of course you are, I can tell. Oh, first, are there any, is anybody adding the course? Any crashers? Okay. Well, if you are, I take all comers. We can add all the way up to a week from this Friday. So all the way up to Friday of the next week, we can add people up to that. So if you know somebody that wants to add, you can send them this way. So let me put this notebook over here. Unfortunately, in my home studio right here, it's very confining. So I have to optimize where I put stuff. Okay. It's over there. My dog was around here somewhere. I don't know where she is now. Anyway, Bella. She was the dog in the picture that I sent. Okay, so we're going to start in chapter 8, in 8.1. Okay. So up to this point in the book, all sorts of stuff has been covered. Let me just outline that real quickly for you. And you can see it if you go up to the front of the book in the chapter contents. But basically, you should know any basic arithmetic operations, even with fractions. Okay, there's lots of fractions in my problems that I covered. So I expect people to know how to be able to work with fractions. And we're even going to be able to work with algebraic fractions as we go along. So just basic fraction arithmetic is something that's very important and that you need to understand. Let's see, what else we got here? Different types of the order of operations and exponent operations. You need to know the order of operations, even if you got a scientific calculator. The scientific calculator knows it, but you have to know it too, just so you know if your calculator is giving you good information or bad. Solving basic equations and inequalities in one variable. You should be comfortable with that and able to do it. We're going to go through word problems. I'm going to be covering a word problem technique tonight. Reading graphs, plotting points, being able to plot a linear equation, a straight line. You should be able to do that in the different forms of linear equations. And again, as we come up to those in this second half of the book, I will review that information as we go up, as we come up to it. Let's see. Exponent properties and operations. So you need to know how to work with exponents, how to work with polynomials. We'll be working with polynomials from the very start. Let's see. How to factor a polynomial, how to multiply and divide polynomials. And again, we'll be working with that as we move along also. Let's see. Factoring is a big one. You got to be able to factor. And that's chapter 5 in the book. So if you are really bad on factoring, and I'll be reviewing those different aspects of factoring that we'll be using as we go along, but you need to be familiar with those. And that's all chapter 5 is factoring. Let's see. So working with fractions and fraction equations, that's all chapter 6. And then chapter 7 is functions and graphs. So again, when I say domain and range, you should understand what those mean. And again, I will be reviewing those aspects as we go along. But now we're going to pick it up in chapter 8.1, section 8.1, chapter 8, talking about systems of equations and two variables. So up to this point, basically, we were solving equations in one variable, or a linear equation where we have two variables. But now we're going to be talking about systems of equations. Okay. Let me roll my thing around here. Okay. And basically, as I do this, I got to move back and forth, and otherwise I block the board. So my whiteboard, as you can see, is rather confined, even though I got the biggest one I could, but it's rather confined. So I have to work back and forth in order to do this correctly. Stand by while I reorganize my notes. This thing here. There we go. There. And this over here. Good. Okay. So all right. So this is 8.1. Called systems of equations. So what do we mean by a system of equations? A system of equations is two equations in two variables, or three equations in three variables. Okay, so primarily we're going to concentrate on the two equations and two variables, but we will look at three variable equation systems and how you solve those also. Okay, so the solution. Let's talk about that. So the solution is the XY ordered pair that satisfies the particular system, that makes the system true. So it's an X, Y, and we call that XY an ordered pair. That, hang on. So the XY ordered pair that satisfies the system. So by satisfying here, we simply means it makes it true. So it makes a true statement when I substitute it in. And we're going to look at an example of that here. In fact, let's look at an example right now. So let's see. Let's look at an example. Example 3 first. Okay. So I'm over in example 3, identify solutions. Okay, and this is, I'm on page 504 in the textbook. So this is example 3. Okay, so here I gotta move my head over to the other side right here. Okay, oops, hey, hang on. And I sort of have to sit down, otherwise my head disappears out of the screen. So example 3 says, we got a system here So this is our system. Now, one of the things that I'm going to do is I write down the system, I number the equations. This is a very important aspect of identifying your system and writing down your system. So this is my system. So I got equation 1. So I have x plus y equals 3. So x plus y equals 3. And number 2. That's not very good, is it? We got 5x minus y equals negative 27. So I got 5x minus y equals negative 27. Okay. Let me write down that top one a little bit better here. Okay, so notice that when I write down my system, a couple of things. One, I number each equation. So each equation is separate. It's its own equation. So I want to identify it. There's equation 1, there's equation 2. Then I line up the x's, y's, and the equal signs. So I line everything up. So it's easy to see the x variable, the y variable, the equal sign, and any numbers that are on the other side of the equal sign. And then I put a line under it. So the line is very important. So the numbers and the line identify our original system. So what we want to do here is we're going to check a point. So we're going to check negative 4, 7. So it says check negative 4, 7. So what that means, the word check means I'm not going to solve the system. We'll get into solving it later on, but I just want to check and see if that's a solution for this particular system. So the way I do that is I substitute it into my equations. So I have equation 1 right here, and I'm going to substitute it in. And as I substitute it in, I'm going to get in the habit of using parentheses. So I'm going to have negative 4 plus 7. Is that equal to 3? So here, when I take them around, I get negative 4 plus 7 equals 3. Yes, that checks out. So that one checks out. Okay. Now I'm going to check 2. 2. So I got 5 times negative 4 minus positive 7. Is that equal to negative 27? So here I got negative 20 minus 7 equals negative 27. And that one checks out too. Okay. So my final answer is yes. That's a solution for this system. So this particular system, that means those are 2 straight lines. If I graphed them, they'd be straight lines. And where they intersect is right there. So this is, yes, negative 4, 7 is the solution, and it's where the 2 straight lines intersect. Note. Negative 4, 7 satisfies the system, and it's where lines intersect. Or cross. So it's where the 2 lines intersect or cross. So if I graphed them, they cross right there at that point. And we're going to solve some systems by graphing as we go along. Okay, good. So any questions with checking? So remember, if on test 1, if I say check this ordered pair for this system, it doesn't mean solve the system. It means substitute it and see if it makes the equations true. Okay. Let's go over here. Okay. I gotta erase my board. Okay. Hang on just a second. It's very dehydrating up here. Okay, good. And let me get my book back over here. Transfer over to this side again. Okay. Okay, now we're going to go back and look. So that's how we check a system. We're going to be solving a system graphically at the end of this section. But before we do that, we want to see how does a system come about? If I have a particular word problem, does a system come about that I can solve just from reading that word problem? Can I make a system? And the answer is yes. Okay. So that's what we're going to do here for example 1 and example 2. Okay. I don't think we're solving them just yet. No, we aren't. We're not solving them just yet, but we're developing our system from these word problems. Okay. I'm going to give you a general word problem solution method later on. But first, let's look at these two things. Okay. So the first one is, so what we're going to do now is make a system from a word problem. Okay, so we're going to make a system from a word problem. And then the way we're going to do this is one of the key instrumental tools for doing this is by using what I call keywords and changing sentences into equations. So the method So let's use keywords to here, wait a minute. Hang on just a minute. One. So we're going to use keywords to make equations. And then 2, we're going to make use keywords to make sentences. Sorry about that. That's what I wanted. And then we're going to change the sentences to equations. Okay. And those equations then will constitute our system. Now, usually anytime I come up with a particular methodology, I'll put a box around it. So that's an important method. That's what one of the key words to solving word problems. So let's look at one right here. Now, what do we mean by keywords? That's keyword, W-O-R-D-S. That should be W-O-R-D-S. So keywords, there we go, are words that mean different operations. Arithmetic, subtraction, multiplication, division, the equal sign. They all have keywords. And these are actually covered up in the front in, let's see, I got a note of that in here. I believe it's up in chapter 2. Okay, well, I'll find out where they are, and I'll let you know with the when I do the review. But up in the front of the book, there's a listing of all the keywords that mean different mathematical operations. I thought I had a note of them right here, but I can't seem to see it right now. But I'll put it up during the review when I put up the review next time. But let's go ahead and look at an example. So this is example 1. Okay, so I have to look at this word problem right here. And as I look at word problem, obviously I'm going to read it. But as I read it, I want to look for sentences. So one of the things with keywords is you can translate a sentence, an English sentence, into an equation, 1 for 1, left to right. So just like subject, verb, object equals left side equation equals right side of the equation. So it translates like that pretty easily. Let's look at an example. So here it says, example 1. In 2016, oh, here it is. It's section 1.1. So the key words right here are 1.1. Pages 4 to 7. So that's where you'll find keywords right there. Section 1.1, pages 4 to 7. I knew I had it in there somewhere. Okay, so this says in 2016, there were 96 species of birds in the United States that were considered threatened or endangered. Okay, I won't read what's in the parentheses right there. So threatens or endangered, that's all I care about. It says the number of species considered threatened was one more than 1/4 of the number considered endangered. Write a system of equations that models the number of U.S. Bird species considered endangered or threatened. Now they use the word model in there. Okay, so don't let that throw you. It's not like a plastic model that you use glue or something like that to put together. What they mean is they want you to make a system, because that system is going to model this particular situation. It's going to tell you things about the situation, and if you solve it, you'll find the solution to that particular situation. So I just read it. Do I understand it? So if you can say it to yourself, then typically you usually understand it. So what do we say? We got these 2 species of birds, threatened and endangered, and the threatened one equals some aspect of the endangered one. Okay, I read that. I think I sort of understand it. So let's go back and look at the 2 equations. So the first one says that, and I don't care what year it was, that doesn't make any difference, but there were 96 species of birds that were threatened or endangered. So the first thing I got right here, number 1, 96 are threatened or endangered. Just abbreviate that. Okay, so 96 were threatened or endangered. Now, typically, one of the keyword aspects here is that the verb of being is, was, has, have is typically your keyword for an equal sign. Okay, so right here, I got a sentence that I can translate directly into an equation. So this says 96 equals, there's the equal sign word right there, R, and then I got threatened or endangered. So I'll use these for my 2 variables. So I'll use T plus E. So the threatened plus the endangered added up to 96. And there I got an equation, 1. Okay, so that's one of the equations for my system. I'll write them up here when I'm done. Okay, there we go. All right. Let's look for another one. Now, the second one uses a little bit of basic arithmetic, and it has a fraction in it. So it says threatened was one more than 1/4 of endangered. So threatened was 1/4 of endangered plus one more. Okay, so what it says right here is threat was one more than 1/4 of endangered. Boom. Okay. Now, a couple of things here. One, I got a verb of being. So that's my equal sign word right there. So everything hinges around the equal sign word. That's the center of the sentence. It's the center of the equation. Notice in English, we got subject, verb, object. So up here, 96, subject, verb, objects, I guess. Okay. So another key word is of. So of means multiplication when you're talking about fractions or percents. Of means multiplication. So I can make a sentence out of this. So this will be sentence number 2. And it says T was, that's my equal sign word right there. And then I get one more than 1/4 of endangered. So I got 1/4 E plus one more. Okay, so notice now I got two equations. So my system then for this one that I just came up with, hang on, I get myself switched around here, sorry. There we go. So my system that I just came up with, I got two equations. So I got one, and I'm going to number the equations. So I got T plus E equals 96. T plus E equals 96. All I did was flip the equation around. You can do that with an equation. Remember, an equation, the left side always equals the right side. So I can flip it around if I want to. So I put the variables over here on the left-hand side, and then the equal sign, and then the number. Okay. And then I got 2. I have T equals 1/4 E plus 1. And I'll put a number in there. So there's my system. Okay. And we have a way to solve that. We're not going to solve it right now. We could solve it very easily, but we're not going to do that right now. But we will be solving that later on. Okay, good. I'm going to take our break about a quarter after right here, but let's look at another problem. So in this particular case, all I wanted to do was come up with a system. Okay, we're not going to solve it just yet. So let me go to the other side and we'll look at example 2. So any questions on this one? Where we use the keywords to make sentences, we change the sentences to equations. Again, and there's where you can find your keywords, section 1.1, pages 4 to 7. Okay, questions? Yes, no, maybe? Okay, good. Then let's go to problem number 2. Okay, so we clean up this side. Okay, there we go. Now we're going to look at example 2. In example 2, we're going to use a little bit different tool for solving example 2. And we've got example 2. Why isn't it here? Ah, there we go. Okay. Good. All right. Okay, so there we go. So for example 2, I'm going to make a system for this, but I'm going to use a little bit different tool. Let me read it first. Okay, so example 2 says jewelry design. Okay, fine. It says Starbright Jewelry Design purchased 80 beads for a total of $39. And they didn't include tax. Okay, to make a necklace. 39 beads, 80 beads, $39 to make a sentence, to make a necklace, excuse me. Some of the beads were sterling silver beads costing 40 cents each. And the rest were gemstone beads costing 65 cents each. How many of each type were bought? And translate this to a system. Okay, so this technique, we're going to do something that's called make a table. So our previous method was using keywords. This is called make a table. Okay. And our table is just a table is like, it's not like a table like you eat on or something like that, but just a table that has boxes in it where I can organize my information. I can organize my information, and from that organized table, I can actually find the equations. It's really nice, and it's a very handy way to do this sort of thing. And we'll be doing more about this later on. Your table is based around some sort of what do I want to say? Some sort of some sort of equation or process that defines that particular situation. And I'll tell you what I mean here in a minute. So let's look at this again. Okay. So this table is based upon buying things. So what are they doing? They're buying beads to make necklaces. Okay. So this is the called the buying cost or buying relationship. This is what you do when you go to the grocery store. So our relationship is what defines this particular situation. And this is the cost. Hang on just a minute. Cost or buying things. So this is a relationship that you do when you go shopping. You go to the grocery store. What do you buy? You buy so much of that thing. It costs so much for each item. Then you come over here, you buy so much of this thing. It's so much for each item of this, and you put all that in your grocery cart. And when you go up to the cash register, then they add up everything right there, and that's your total amount that you owe. Okay, so how does that come about? So that is the cost is equal to the amount times the price. Cost equals amount times price. So the amount in this case is how much of an item do you buy? So the total cost that you pay at the cash register is equal to the number of items that you buy, how many of that thing that you buy, times the price per item. Okay. Now our table is based around this relationship. So this is how we make the table. Okay. So now I'm going to make the table. So I have item. And then along the top right here, I have my relationship in reverse order. So they have the amount times the price equals the cost. So that my table is always based upon my relationship that defines that particular situation. And we're going to come up with about 5 or 6 different relationships. And some of them you might already know, you just never thought about it in that context before. And then down here, I got my particular items. So what am I buying? I'm buying 2 kinds of items. I got, what do I got? I got silver and I have gemstones. So I got silver items and I got gemstone items. So I got 1, 2. And then I got total. Okay. So this one, and then this divides up my subdivides my system right here. So you can see I got a table of things right there. So I got a column here, column, 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 and row, row, and row. All right. So let's fill it out. Use a different color here to fill it out. So my 2 items, what are my 2 items? I have silver and gems. Silver and gemstones right there. Okay. So what they asked me to find, they said, where did it go? There it went up there. How many of each type were bought? So how many of each type were bought? Somewhere in the problem statement, it asked me to find something. So that's what they're asking there. How many of each type? So those are my variables. So that's this pipe right here. So I'm going to have silver and gems, S and G. You could call it X and Y also if you wanted to. That's okay. And then I got the price. They told me the price. So the silver ones are, where'd they go? So the silver ones were 40 cents each, 40 cents each. Now, notice a couple of things here. So they were 40 cents, the gems were 65 cents, but then the total was $39. So this presents a confusing aspect. When you're working with dollars and cents, you got to either work with all pennies, all cents, or you got to work with dollars. Okay, so let's work with pennies. Okay, so if I work with pennies, then this will be the silver was 40 and the gems were 65. So 40 and 65. Okay, then over here is the cost. So right here is the relationship, where the relationship comes in. Notice this times this is equal to that. So this is 40S. This times this is equal to that. That's 65G. Okay. Now, I got some blanks down here also. So the first thing is they gave me a total cost. So it said the total cost was $39. Now I got to work in pennies or I got to work in dollars. So I decided to work in pennies right here, 40 and 65. So $39 is how many pennies? Anybody? It's 3,900, right? 3,900 pennies. So this is going to be 3,900 right here. Okay. If I was working in pennies, that would be, or if I was working in dollars, that would be 0.40 and 0.65. And we'll look at problems like that later, then that would be 39. Okay. Now I got another one. It says the total amount of items that they bought was 80 beads. So where does the 80 go, do you think? Right here, the total amount. 80. Okay. Now, here I don't need anything. So I'm just going to put an extra there. Now, the thing is, I'm going to show you where the two equations are. You can think about it, and then we come back, we'll make our system. So here's an equation right here. There's an equation right there. And then here's an equation right here. Notice S plus G equals 80, and the cost of the silver plus the cost of the gems is equal to $39. Okay, so let's take a break, and we come back, we'll write that system up there. Okay, so what do we got now? So now it is 8:22. So at 8:32, the math train will leave the station. Okay, I got to make a pit stop. I'll be right back. Don't go away. Okay, I'm back. Yay. So any questions so far? Any administrative type questions?
Nothing really. Everything's going good.
Good.
Thank
Is
you.
everybody able to see the board? So I'm able to write stuff up there without blocking it too much?
Yes, sir. Perfectly fine for me.
Okay, good. I know my lamps that I have for light in here cause reflection off the board. So far, I haven't found a way to get around that. Looks like we got a pretty good turnout. 20 people out of 26. That's good.
So I have a question, Mr. L.
Yeah.
I haven't gotten my textbooks yet, and hopefully someday this week, hopefully tomorrow after my 9:30 class, I'll just go to the library or the bookstore and just get all my textbooks situated. Because I don't know if the bookstores there at the Mesa have the actual. Do they have the actual copies?
Yeah, they should have actual copies.
Okay. Because
They
I'm
have a reference. They have a reference copy in the library also.
For sure. No, because I'm more of an old head. I don't like digital stuff nowadays.
Yeah.
That
Well, that's
that's
why
why I took a gap.
the cheapest avenue is to rent it.
Yeah,
And that's usually a pretty good way to go.
for sure.
And they pay let's see, I think somebody is renting it. I know a couple people are. I don't know if anybody put it down on the chat there.
I'm renting it, but I can't remember how much I rent it for from the
Okay.
campus bookstore.
Oh, you rented it through the bookstore? Yeah, you can rent it through
Yeah.
the bookstore. Mhm.
I mean, I'm not worried about the price. I just need to get the book so I can actually start doing everything properly.
Yeah.
Yeah.
Well, the quickest way then on campus is to rent it through the bookstore.
Yeah, that's what I'll do that tomorrow. Thank you.
Sure.
Because I didn't want to wait for it and it'll come here like in a week or two while we're doing homework already, you know.
Yeah.
Yeah.
And then like the geometry book, we aren't going to be using that for several weeks. So
Okay. So that can wait until like a week ahead before we
oh yeah.
for sure.
And you can usually buy a hard copy of that through Amazon or someplace like that for like hardly anything, you know, maybe $5, something like that.
For sure.
Okay, good.
Yes, sir.
Say, Mark Dallas. So you sent me an email. Are you there? Oh, there you are. So you were in the Navy?
Yeah, I'm here.
Oh, okay.
I was in the Navy.
Okay, good. And now you're not?
Did some sailing. No,
Okay.
I'm not.
All right. Cool.
It's been a while.
Yeah, it's been a while for me too, but I was in there quite a few years.
I finished and I went to a small shipyard. And then when that got too scary, I decided to stop doing that.
Oh, you mean like NASCO or someplace like that? Or
So I was at a
Southwest?
small subcontractor.
Oh,
but
I
we
see.
had to work on NASCO and BAE and everything.
Oh, okay. Yeah.
It's scary
Yeah,
out there.
I picked up a ship in the shipyard once at NASCO, and that was a scary proposition just walking across the shipyard in the morning.
Yeah. Stuff, not many safety precautions being followed.
No, that's for sure. Yeah. And I don't think they gave us hard hat. We didn't have hard hats or nothing.
I have so many hard hats now.
Okay, good. I can see somebody did put up a link to, it looks like a book rental site there. So Angeles Vega put one up there. Ah, it's good to see you again, Angeles.
It's nice to see you too, Professor.
Yeah. So it says online book for free if you need it in the meantime. So what do you mean? You can download a digital copy?
Yeah, so it's a digital copy. It's online. You just have to rotate it because it's not uploaded correctly.
Uh-huh.
But I know there's some people who prefer a physical book rather than an online ebook, but it's the whole book online. for
Yeah.
free.
At the website that you have indicated there?
Correct.
Oh, okay. So that's not a website where you can rent a book? You could just get the digital one?
Correct. You could just get it on one of those websites that uploads books.
Okay. There's another one up above that too.
Yeah, I
it's
think somebody
basically-
uploaded
that's
one
the
that
same one.
Oh, is
it's for
that the
like free
same one?
books in general.
Okay. So now, I mean, textbook, the thing about textbooks is the whole price system on textbooks got so outrageous that basically students and anybody else that had to use them in the college level, they just revolted. And they said, there's got to be other options. So that's why there's even some free textbooks now that I'm using one for my other class through a thing called OpenStax, but not for this class right here. Oh, okay. So it's 8:32. So it's time for the math train to leave the station. So let's take a look at our and review what we did for example 2. So in example 2, we got a basic word problem, but we're going to make a system from the word problem. So our method here is called make a table. So make a table is just an option that we can use to organize the information in the word problem. And from the table, we get the equations right out of the table. So the table is based around some relationship for that particular problem. In this problem here, we're buying things. So it's what I call the cost or buying relationship. So the cost is equal to the amount times the price, or the cost that you pay at the cash register is equal to how much each item is, or how many items that you buy rather, times how much each item is. Okay. And then we make our table. So over on the left-hand side of the table, we have our different items. So here we got silver beads, gem beads, and there's also a total also. Always put the total in. Across the top is our relationship, and we put that in there backwards so that the equal sign is over on the far right-hand side. Now, the author doesn't do it this way in the book. So I don't like the way the author does it in the book. It's sort of like backwards and upside down. So this, I think, makes a lot more sense. And so then you just go across and you fill out the stuff that you know. So somewhere in the problem, they ask you to find something. So here they ask us to find how many of each type of bead. So those are our two variables. Here I got S and G for the two variables. And then they told me the price of each one. So one was 40 cents, one was 65 cents. And then you just follow the relationship across to fill out the last column over here. That's why you leave the last column is whatever was on the right-hand side of the equal sign. And that's over here in the last column. And so then you follow the relationship right across. So this times this equals that, 40S. This times this equals that, 65S. And then we got down at the bottom, you got a total row down here. So they told us the total number of beads. There was 80 beads. And then they told us the total cost that you paid, which was $39, which is actually 3,900 cents. So when you're in any kind of problem, if you have dollars and cents in it, some things are pennies, some things are indicated in cents, some things are indicated in dollars. You got to make everything to the same monetary unit, either dollars or cents, one or the other. Okay. So here we elected to do this all in pennies or cents. So I got 40 cents, 65 cents, and 3,900 cents is $39. Okay. And then just following it down like this gives you your equation. So this plus this is equal to that. This plus this is equal to that. Okay. This is the total or whole is equal to the sum of the parts. That's what that relationship is right there. So now from this, I can make my system. Now let me go back over to this side here. There we go. Again, I number my equations. So number one right here, I got S plus G equals 80. Okay, let's write down that one. Number two, I have 40S plus 65G is equal to 3,900. And then I put a line under it like that. So I got my two equations. I numbered them. I lined up the variables and the equal signs, and then I put a line under the system. And that's my original system. And we'll solve problems like this later on. Right now, we just want to write the system down. But here, the method I'm using out of this word problem was what I call the table method. Okay, let's see. Okay. Good. Let me give you a little word problem method to follow. I got a blank space right here, so I'm going to write that down there. So this is just a general word problem method. I got to go over on this side. Wait a minute. So what this is just a basic strategy when you're trying to face any kind of word problem and you want to solve it. So what do? So the first thing is it's a word problem. Let me get my books out here. So it's a word problem. So basically you got to read it and understand it. So one, read and understand. Let's understand. So it should be an ER there in the middle. Okay. So the second, once you read it, you understand it. Usually if you can say it back to yourself in other words, typically you probably understand it. Another thing you can do to help understand is list items. Make a list of different things and that helps you put it together. But the second thing I'm going to do is make variables. Okay, so it's all about algebra. So that means we're working with unknown quantities. So we have to make variables to indicate those unknown quantities. But once I get the variables made, then 3, I can make equations. That's actually the hardest step, is making the equations. And that's why this table method is so nice, because the equations just fall right out of the table once I get everything indicated in the table. So what do? Once we make the equations, now we have our system, so then we need to solve the system. Okay. Then once we solve it, the last thing is we got to check our solution. Whoops, hang on. There we go. Yeah. And that's a good technique to follow when you're approaching any kind of a word problem. Okay. Especially in algebra, because we can do it with variables, equations, and solutions. Okay, good. Let's see. What do we got next here? This way. Good. Okay. So now we're going over to what do I want next? Yeah, we're going to solve a system graphically. So now we're over on page 504, objective C, which is solve system graphically. So this is our first solution technique to solve a system. Incidentally, as I go along, I'm going to be sending this back to you on my YouTube site. But if you want to take a picture or anything as I'm going along, just say so and I can stop and you can take a pic. Okay, good. Now, just a minute. Let me clean up this side. You know, I had to get my other eraser there. Yeah, that's not going to work. Okay, good. So the book is laid out by objectives, and I usually like to follow the objectives. So we already did objective A and B. So A was translating, which means just to develop a system either by translation, like we did for example 1. So translating keywords into equations, equations or sentences, and then sentences into equations. That gives you your system. Or by making a table, as we did in example 2. And then B was identifying the solution. In other words, check a solution. So check a solution, we substitute, do the arithmetic, and see if it satisfies the equations. So now we're looking at objective C, which is to solve a system graphically. Hang on. So we're going to solve a system graphically. So what does that mean? That means we're going to graph each of these equations that we got. And you can see they're all linear equations. So there's everything is to the to an exponent of 1 plus 1. So that means they're linear equations. So I should be able to solve it graphically. So let's look at an example. Okay. So, well, let me write down a method first. So method. So the method, we're going to graph the equations, and then the solution is their intersection. Yes. Okay, so there's our method that we're going to use. So graph the equations, solution is intersection. Okay, good. So let's look at an example here. So this is example. Oh, the author has several different examples. Okay, let's look at example 4. Okay, good. So example 4, we got 3 different examples that we're going to graph, and each one represents a different type of solution. Okay. So this is example 4. I'm going to start out with 4A. So with 4A, I have, let's see. Let me go over here. Y minus X is equal to 1. And then Y plus X equals 3. Now, typically when I write down a system, I put stuff in alphabetical order. So X comes first, Y comes second, X, Y, Z. A comes first, B comes second, A, B, C. So typically it works better if you put things in alphabetical order, just makes it easier to understand. A lot of times this author messes things up and mixes up the order. And I think he does that purposely to confuse students. So I'm going to put it in alphabetical order. So the first thing I got, I'm gonna write down my system here. I got minus x plus y is equal to 1. So negative x plus y is equal to 1. And then 2, I got x plus y equals 3. X plus y equals 3. There's my system. Okay. Pretty straightforward system. So now I'm going to graph that system. Now to graph it, notice the coefficients right here are all 1. That's a -1, but all the rest of them are +1. So what does that mean? So that means this one I can solve real easy with what I call the intersection or the hand method. I'll show you what I mean. Okay. So let me make my graph over here. Okay. Let's see. Hang on. I got to go over further. Okay. Hang on. Usually I can draw better graphs than that. I'm just sitting at a skewed angle right here. In fact, let me put the graph up here so we can see it better. There we go. 1, 2, 3. 1, 2, 3. Okay, good. That's my X. This is my Y. So one of the things I want you to get in the habit of doing is anytime we do graphing is you have to label the system that you're graphing. In other words, you got to tell what the axes are. So the horizontal one is X, the vertical one is Y, and then you have to put down the number designations of the coordinates. So this is 1, 2, 3, 1, 2, 3, -1, -2, -3, -1, -2, -3. Okay. So there's my graph paper. It's all up there. Okay. Now, over here, I'll show you what I mean by the hand method. Yeah, let me come over here a little bit. Okay, so let's look at number 1 right here. So I got minus x plus y is equal to 1. Okay, so now this is the intersection method. So notice if I put my hand over it, it goes away. That means its value is 0. So if I put my hand over the x, x is 0. What's y? Y is 1, right? So that gives me an intersection point for this one here. So when x is 0 everywhere on the y-axis right here. So if x is 0, y is 1. So that means there's a point right here. Okay. My second one, if I put my hand over the y, if y is 0, x is what? I got minus x is equal to 1. So x is equal to -1. So if y is 0 everywhere on the x-axis right there, then x is equal to -1 right here. Okay. And now I can just connect those dots. Notice if I connect them, there's going to be a dot here, a dot here, a dot here, a dot here. So this line goes right through here like this. And that's equation 1. Let me write down equation 2 right here. So equation 2 says x, this is even easier, x plus y is equal to 3. So if I put my hand over the x, it says y equals 3. So if x is 0, y is 3. So x is 0 again anywhere right here. So y is 3 right here. Okay. If y is 0, x is 3. So y is 0 on the x-axis. So x is 3 right here. Okay. Then I just connect those two dots. So connect those two dots, comes through here like this, and goes out this way like this. So that's equation number 2. Okay. So, where's the solution? Where the solution is where they intersect. So where do they intersect? Right there. I can tell it. Even on my rough graph right here, it's pretty easy to see. So I can see the intersection is going to be right here at the point. I'll write it over here. X is equal to 1. Y is equal to 2. So 1, 2 is the solution for this particular system right here. Solution 1, 2. Okay.
Can we use the hand method regardless of the coefficients? Or is it just for when they're 1?
Oh, you can use it for other coefficients too.
Okay.
But if they're 1, it works real easy. So I can do it real quickly.
Okay.
Yeah. If there's a coefficient in front, then I gotta deal with fractions. Okay. So if it's 1, you don't have to deal with fractions. That's the beauty of that one. So if all of the coefficients are 1, it makes it real easy to graph the system. All right. Let's look at what we're going to look at somewhere it's not 1. I think in the next one has that one. Okay, good. All right. Okay, so let's look at B right here. All right. Let me go over this side. So this was item A in example 4. Let me clean up this board here. Okay, there we go. So this is example 4, item B. So once again, we're going to solve it graphically. So the first thing I'm going to do is I'm going to write down our system. Okay. Now, I notice when I look at item B right here, the author has already written it in a form. Linear equations have 2 forms. Let me back up just a step, a little bit review of linear equations. So the 2 forms of linear equation are 1, the standard form, and the standard form is this: ax plus by is equal to C. Okay, and then we have slope intercept. Which is this: y is equal to mx plus b. Okay, so our first system, they were all this form right here. Okay, where the A's and the B's were all one, so it made it real easy. But this second system is in this form right here. Okay, so let's look at the second system right here. Anyway, those are our forms of linear equations. Okay. So our second system. So number one, we have y is equal to minus 3x plus 5. And then 2. We have y is equal to minus 3x minus 2. And there's our system. Now notice, the coefficient of the x is the m term right here. That's the slope, okay, for slope intercept. So m is the slope, b is the y-axis intercept. So right here, this one has a m is equal to -3 over 1. And we always make it a fraction. So -3 over 1, and b is equal to 5. And equation number 2 right here, m is equal to -3 over 1, and b is equal to -2. Okay, so I just wrote down with the slope and the inner, because that's how I want to graph them. And I'll graph it over here. So again, let me make our graph right here. And let's see. The y has to go to 5 and down to -2. Okay, good. All right. That's the x-axis. Okay, and this is the y-axis. Okay. So there, I've drawn my coordinate system and I labeled my graph. Okay. So now I'm going to graph these. So when you graph these, the first one here, equation number 1, you always put a point at the y-axis intercept. That's B. So here B is 5. So I put a point right there. Okay. Now notice the slope is -3. So when you write down the slope, you always make it a fraction. So -3 over 1. I can make any whole number a fraction just by putting it over 1. So I got -3 over 1. So I always go out in the, it's always, dang it. The slope is always change in y over change in x. Slope. Let me write that down over here. Okay, and sometimes we call this delta y over delta x. The Greek letter delta is a triangle like that, and all it means is change in. So this is here. Change in. Okay. So the change in a y over the change in x. So you always start there and you go out in the x direction, and plus x direction, the denominator number. So here the denominator number is 1. So I go out like this, 1 in the plus x direction. And then if it's negative, I go down. If it's positive, I go up. So the change in y is -3. So I go down 3. 1, 2, 3. And I put another dot. So I put a dot right here. And then I can do it again. I go out 1, down 1, 2, 3. I can put another dot right there. Right? And I can connect the dots. So then I just connect the dots and it should connect in a straight line. Okay, so that is equation 1. So equation 2 has a y-axis intercept. The b is -2. Okay, so right here at -2, I put a dot. Okay, now the slope is -3. So that means I go out 1 and down 3, but I can also go in the opposite direction. So instead of going the x that way, I'll go x this way, and then I'll go up 3. 1, 2, 3, and I'll put a dot. In other words, what I did was I moved the negative sign from the numerator down to the denominator. So I went out 1 in the negative x direction, and then I went up +3. I go out 1 in the negative x direction and up +1, 2, 3, and I put another dot. Okay, and I connect the 3 dots. And there's 2. Okay. So what does it look like on this one right here? Those 2 lines look like they're what? Anybody?
Parallel?
They're parallel. Yeah, exactly right. So they're parallel. So what does that mean? That means they'll never intersect. So there's never a solution. Okay. So the solution to this set is what we call, to this system is what we call the null set. And we know they're going to be parallel because of right here. Right here. The 2 slopes are the same. So if M1 equals M2, slope 1 equals slope 2, then we can say that's parallel lines. I don't even have to graph it. It's parallel lines. And if the lines are parallel, that means the solution is what we call the null set. So the way we write that down is we say that we can say there's no solution, or we can say that the XY solution is equal to what we call the null set. Null set. And all that means is the set with nothing in it, or we can say no solution. Okay. So I didn't even have to graph this. I just graphed it to demonstrate that the slope intercept graphing technique, and so that you could see that they're parallel lines. Okay. Now we have one more example right here. So let's look at item C in example 4. Okay, we clean up the board once again. So this is example 4. C. To solve graphically, okay? So let me write down our system. So the first one we have, and again, I'm going to put the X terms first, just to put things in alphabetical order. So I got minus 2x plus 3y is equal to 6. The second one, I have 8x minus 12y is equal to negative 24. There's my system. You can see it's written in standard form, ax plus by equals c. Okay. So in order to graph this, I'm going to have to, I'll put it in slope intercept form. So what I'm going to do is solve each of the equations for y. Okay. So number one, here, I'll do them in a different color. Yeah. Number one. So I'm going to solve it for y. So there I'll add 2x to both sides and I'll divide by 3. So what I'll get is dividing by 3, I get 2. Oh, excuse me. Y comes first. So I get y is equal to 2/3 x plus 2. So that's what I get when I put equation 1 in slope intercept form. Okay. Let's do equation 2. Equation 2. So again, I'm going to solve it for y. So let's see. So on this one here, I'm going to get, let's see, negative 12y is equal to negative 8x minus 24, or y is equal to 8/12 plus 24/12, or y is equal to, so I got 8/12, that should be an x right there, 8/12 x plus 24/12. So 8/12 is 2 times 4 over 3 times 4. So I get 2/3 x plus 2. And notice, not only did I get the same slope, I got the same y-axis intercept. So what does that mean? That means this is the same line. So if I graph this, I could graph it. Let's graph it. Let's see. So the y-axis intercept is 2. Okay, I can handle that. And the slope is positive 2/3. Okay, good. I can handle that too. So here's x. I got 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. Here's my y. Here's my x. Okay, so there my graph paper is drawn. So let me draw each of the lines on there. Okay, let's see. The green is the lighter color, so I'm going to put green on there first. So I got a y-axis intercept of 2. And I got a slope of 2/3. So that means I go out 2 and up 3. So out 1, 2, up 1, 2, 3. And I put a second dot. It goes a little bit off my graph. I can go in the other direction too. 1, 2, down 1, 2, 3. I can put a dot right there. But anyway, there's my green line. So it's going right through here like this. Now let's do the blue line right here. So again, it has a y-axis intercept of +2. So it's in here also. There it is right there. And it has a slope of 2/3. So 1, 2, 1, 2, 3. So it has a dot right here also. And then this way here, 1, 2, 1, 2, 3, and a dot right here too. So notice this way you can see that they're the same line. So here's equation 1. Here is equation 2. So same line. Yeah, let me write it down here. Let me make some more room down here at the bottom. So if it's the same line, it has infinite solutions. So the way we designate, or the way we show what the solution is we use what's called set builder notation. And the way we do that is this. So we say that the XY solution is going to be the set. So use set notation. So I use the brace right here, the set of all XY such that, and we do a long vertical line, that means such that, and then such that, and then you write down any equation. So I can write down this first equation right here, negative 2x plus 3y is equal to 6. And then I close off my braces. And that's how we write down the solution set right there. Okay, and that's called set builder notation. I'll write that over on this side over here. We use what's called SET, set builder notation. So in the first example, A, we saw we had one intersection, one solution. In the second example, B, we had parallel lines, no solution, okay, or the null set. Now we have the same line, and it might not always be obvious that this is the same line. I mean, when I wrote them down there, they didn't look like the same until I actually put them in slope-intercept form. And then I found out they not only have the same slope, they have the same y-axis intercepts, same line. So that means there's infinite solutions. Put that up here. Then in this case, where it's the same line, let me write it over here. So for same line, we have infinite solutions. So that means anything, any XY ordered pair that satisfies one equation will satisfy the other equation also. Okay, so that brings us to our last topic in this particular section, which is, well, the author doesn't actually have an objective for it, but it falls under this objective right here, but it's over on page 506. And what I'll do is I'll simplify it, and we call this types of solutions. Okay, so any questions so far on our different types of solutions that I graphed right here? Okay, especially my two different ways of graphing a linear equation with slope-intercept form, or if I graph it in a standard form with the hand method, the intersection method. Okay, good. Let me go over to the other side again. Let me clean up this side. I was thinking I'm going to have to hire somebody to erase the other side of the board as I'm doing this. That's going to save a lot of time. we go. Okay, so this is our last topic in 8.1 right here, where we're going to talk about types of solutions. Okay, so we're going to keep it simple and have three basic types of solutions. So the first one is called a consistent system. And yeah, this is also types of systems. In fact, maybe I should put that up there, types of systems. That makes more sense. Let me do that. But we'll talk about solutions for those systems as we talk about them. So the first one is called a consistent system. Okay. So in a consistent system is intersecting lines and you have one XY solution. So consistent system. Intersecting lines, one solution. So intersecting lines, one XY solution. So what we'd see over here, if I did it graphically, got my X, I got my Y. So I'm gonna have one line, have a second line. And there's my XY solution right there. So one XY solution. Okay. So if I have consistent on one side, then I can have inconsistent on the other side. So in meaning not consistent. So inconsistent. So an inconsistent system is going to be parallel lines. So I'm going to have parallel lines and no XY solution. Okay. No XY solution. Or one of the other ways we could express that is we could say that XY equals the null set. Okay, as I mentioned before. So in this particular case, then we'll have it like this. So just have two parallel lines like this. One, two, and they don't intersect. Okay. Then the last one we have is called a dependent system. So the word dependent implies that one equation depends on the other. So in a dependent system, we have the same line. And I have infinite X, Y solutions. Okay. Or we say that in this particular case, and the way we express that is we use set builder notation. So I say X, Y is equal to the set of all X, Y such that, and then I just write down one of the equations. Y is equal to MX plus B and close off my set notation. So here graphically, then it's going to look sort of like this. Systems are running into one another here. There's my X, there's my Y. So I got one line. There's one. And all for that, I have two lines. There's two. Okay. So one line's right on top of the other line. Okay, so those are our basic three types of systems. Okay. And all I care about is these three keywords right here. You want to know consistent, inconsistent, and dependent. Now the author throws some other words in there too, but those are the three keywords that I want you to key on: a consistent system, an inconsistent system, or a dependent system. Okay, does that make sense? Yay, of course. All right. Dang, what time is it? We're running out of time. Wait a minute. Hang on. I always got to double check. Oh, the class ends at 9:30. Okay, so I got a few minutes left. Okay, good. Okay, so we can get started in the next section anyway. Again, I'll be sending you the homework problems. So when I'll send you an email either tonight or tomorrow morning, depends on how long it takes to upload it to my YouTube site. I'll send you the YouTube link, and I'll send you the homework problems. So I'll send you that, and I'll also put the homework problems on Canvas. Okay, so we won't be turning in homework on Canvas, but the problems will be there in one of the modules. You'll see the homeworks if you just go to the module section. Okay, so next time we'll start 8.2, and we're going to look at solving systems of equations. Okay, and we're going to see that we've already had one method of solving systems of equations, and that's by using by graphing them. But a lot of times you can't get an accurate solution, especially if the intersection point is between graph lines, then you're going to have to estimate the solution. So you won't get a good solution. So in 8.2, let me go over here. We're going to look at two more methods of solving a solution or solving a system of equations. We're going to look at two more methods over here in 8.2. So we're going to look at what's called a substitution method and an elimination method. So we're going to look at one, which is called substitution. And two, elimination. Okay. So we're going to look at two more systems of solving the equation. Those two systems there, the substitution method and the elimination method. And why? Because you don't always get an accurate solution with doing it graphically. And doing it graphically is a pain because you gotta make graph paper, you gotta graph the lines, and then even when you graph them, you'll find that they don't intersect at graph line intersections, which means that you got to estimate the answer, which isn't going to work. So especially if you got a fraction or decimal answer, it's not going to work. So we're going to look at two other methods for solving systems here in 8.2. And ladies and gentlemen, boys and girls, that's all I got for tonight. Whew. Any questions up to this point?
No, sir. Everything seems fine for me.
Okay, good. So I hope you're able to read the stuff on the board. I know I do have some light reflection on here. Unfortunately, I'll try and figure out a way to eliminate that. But yeah, so far I haven't been successful. And plus it's confining for me going back and forth right here. But if anybody can make recommendations, I'd appreciate that. So again, don't forget to sign into the chat over on the right-hand side there so I can get your attendance. And if you made any comments, that's good too. Okay, so people made some book comments over there. Okay, good. Yeah, good comments. All right. So any other questions on anything? The syllabus, my methodology, how I conduct the classes, whatever. Okay.
For the notebooks,
Yeah.
is that okay? Because I have one complete notebook for like all of my subjects. Is that okay for your?
Yeah. No, you can put more than one course in a notebook if you want. That's fine.
Okay, for sure.
Yeah. Just have the algebra section so I can see where it is. Yeah.
Yeah, for sure. Thank you.
Okay. Well, that's all I got then.
Yeah.
Everybody,
Thank you, Mr.
have a
L.
nice evening. We will see
You
you
too.
on Wednesday.
Yes,
Have
sir.
a good night, Professor.
Have a good night, y'all.
You too. Yeah.
Good night.
Good night. Everybody.
Yep, thanks for the help, Mr. L.
Yes. Do you have a comment?
No, I just said thanks for the help. I'm logging off.
Okay. We'll see you next time. Yeah. Okay. Well, I'm going to stop the recording now and 1 more minute and I will stop the recording. Bella. Hello, Papa. Hello. Puppy dogs. Yeah, there we go. Okay, so I can stop the recording. Good night, everybody. Good night.